Well, hello, people of the internet. It's been a long time. So today I thought I'd come back and do a quasi short video on a pretty cool piece of technology called Eigrp over the top, or OTP. And in this video, we'll go through configuring OTP, setting up a route reflector, and also securing our OTP traffic with Getvpn. So high level, what is OTP? Eigrp OTP allows routers to form Eigrp adjacencies over a layer 3 WAN. So this could be the internet, this could be your private MPLS network, which is likely what this is designed for. Either way, it uses Lisp encapsulation so that the WAN in the middle doesn't have to have any of your routing information for your private subnets. You just have to have reachability between your routers. So for our demonstration, our WAN only has routes for these 172.16.253 networks. We have CSR1, who will be our OTP route reflector, CSR2, who's a OTP customer edge or CE, and CSR3, who's also another CE. And the goal here in phase 1 without doing any encryption is just to get CSR2 and 3 to form Eigrp relationships with CSR1 and be able to route traffic directly to one another to these 10.1, 10.2, and 10.3 subnets. And then after we get OTP up, we'll come back through, we'll configure KS1 as a Getvpn key server, and then set up Getvpn. So, without further ado, let's go. Get started on CSR1. I'll actually try and blow this font up a little bit so that we can actually see it. And first things first, let's see what IP addresses we have right now. We have loopback 0 acting as that 10.111. I think I have a /32 mask on there, so just to keep the diagram accurate, we'll do 10.111, 255, 255, We get a /24. Then we'll go into router Eigrp. We're going to use Eigrp named mode, so I'm just going to give mine OTP, keep it simple. And we're going to go into address family IPv4 unicast with an autonomous system of 1024. And first I'm just going to put my loopback adapter in there. And then I'm going to set this up as the route reflector so it gets a special remote command. And that is remote neighbors source. We're sourcing this traffic from gig 1. And we're going to do unicast listen, Lisp encapsulate it, and then I'm going to provide a Lisp ID, and we'll just do 123. You'll see that actually brings up a Lisp 123 interface. That'll have the same IP address as gig 1. Cool. So we'll go to CSR2. Again, we'll make the font a little bit bigger. Go router Eigrp, named mode, we're going to name it OTP. Go to address family IPv4 unicast with autonomous system number 1024. We'll advertise the network of 10 to, oh, sorry, just do all 10s there. And then we'll do neighbor of 172.16.253.2. We're going to say that this is going to go out gig 1. It's a remote neighbor. It's going to ask you how many hops away you want to allow. I'm just going to put 10, even though really this emulated WAN is actually just one router. And then we're going to specify that there's Lisp encapsulation, and we'll set the Lisp ID as 123. And you will see that neighbor pop up. I'm going to fix the subnet mask on this loopback while we're here too. The address 1022. All right, so then we have a /24 route over this Lisp tunnel. So we'll come to CSR3. Do the same thing. 253.2, out gig 1, this is remote, 10 hops away, and Lisp 123. And then while we're here, we'll do address 10.333. So we'll see we actually only have routes to the local network of CSR1 right now. So to finish the configuration of CSR1 as a route reflector, we'll go back into our Eigrp config, go back into address family IPv4 unicast with autonomous system number 1024. We're going to go into address family interface or AF interface, gig 1. You can't actually configure the Lisp interface, so we're going to do the split horizon, no split horizon, and no next hop self config on gig 1. So we'll go into here, we'll say no split horizon, no next hop self. And now if we come back to CSR3, we should have routes for both 10.1.1 and 10.2.2. And you'll notice that the next hop address for 10.2.2 is actually the IP address of the WAN interface of CSR2. So, even though we're only forming an Eigrp adjacency to CSR1, we do have direct reachability to CSR2. We're not doing like a hub and spoke here. We can confirm that if we go into GNS3. Let me just stop this capture, start this capture, fire off Wireshark. You'll see if I come to CSR3 and ping 10.222 and I source from my loopback 0, you'll see this traffic 4343 as coming directly between CSR3 and CSR2. Well, actually, let's decode that really quick. Let's go into analyze, decode as, we'll add 4343, and we'll set it to be Lisp data. Now you can actually see that when we decode it, you can see that it's completely unencrypted, right? It's just a Lisp header on the top. So we have our original IPv4 packet, or our outer IPv4 packet that is destined to 172.16.253.10. That's the outside or WAN IP of CSR2. Sourced from 172.16.253.14. That's the WAN interface of CSR3. And then since we've decoded this in Wireshark, we can actually see the encapsulated payload of ICMP traffic from 10.333 to 10.222. So that's actually it. That is setting up Eigrp over the top with route reflector, setting CSR3 as a route reflector. So let's take this a step further and let's set up Getvpn. So to do that, I'm going to do the bulk of the configuration. If you've ever set up Getvpn, the key server is doing all the heavy lifting. I have this key server just with IP addressing and routing on there right now. So we do show IP route. All we have is a route for all traffic to go out through 172.16.253.1. That's fine. And it's reachable on the same, it's actually this interface here on our WAN connectivity is going through a switch. So it's not really illustrated in the diagram, but I got lazy. Anyway, the things that I'm going to do on this key server is I'm going to set it up as NTP master, then as certificate authority. I'll pull certificates from all the CSRs, enroll them through this key server, and then we can start setting up Getvpn. You could do this with a pre-shared key, but I find that Getvpn works a little bit better, in my opinion, when you use certificate-based authentication, and it's just not that hard to set up. It just takes a minute. So we'll do that. So first things first, I'll say that this is NTP master, and I'm going to set Let's just do that. We'll just set NTP master for right now with a stratum of 1 because, for these other routers, they don't have to know that there's better time servers out there, right? Do server is 172.16.253.3. We'll do, I think this is on by default now, but we'll do burst and iburst. And we'll get those clocks syncing right now. And then on the key server, we're going to do crypto PKI server. Actually, let me do this first. Set a domain name of hop16.com. I'm going to start taking some of the stuff that'll have to get recycled on the other routers and drop it in that notepad too. All right, so crypto PKA server ksca.hop16.com. We're going to do grant auto so that as soon as the enrollment request comes in that we just auto approve. Probably not great for production, but perfectly fine for our little lab here. I'm going to set our hash at SHA-256. I'm going to set the issuer name to be the common name of ksca.hop16.com. We'll set the database URL to be flash. Let's see. And I think that's all I want to set for now. We'll create a password. Oh, there we go. Let me set the clock really quick. Say clock. ST -5. Clock, summertime, EDT, reoccurring. Set is 14. This doesn't actually have to be accurate, but I'm going to make it accurate. 3 of August 2022. We'll come back into our certificate authority config. Now we'll no shut. And since this server, or this router is going to be doing a couple different things, it's going to act as the certificate authority, and it's also going to be the Getvpn key server. I'm actually going to have to request a certificate from myself that I can use for the Getvpn config. So not only am I going to be the CA, I'm also going to configure this like I'm a client as well. So let's say crypto PKI trust point. I'm going to name that trust point KSCA. Again, I'll set the hash as SHA-256. I'll say the subject name for the certificate is going to be ksca.hop16.com. Actually, let me change that. It's going to be cn equals, common name is ksca.hop16.com. We'll say fqdn is ksca.hop16.com. And we'll say the enrollment URL is http 172.16.253.3. That's the WAN IP address of this key server. And then we'll do crypto PKI. We have to authenticate it first. We accept that fingerprint. And we'll do crypto PKI enroll KSCA. I'm going to say no, no, and then I do want a request from that certificate authority. And we'll see that we get a client certificate that we can use for Getvpn now. And just do a quick show history to see if we can still grab any of the stuff. Nope. All right, so this will actually be able to be recycled on the other routers so they can request their client certificates. So we'll keep the trust point name the same. The only things that will change router to router will be the subject name and FQDN. So we'll start here. We'll authenticate. We'll enroll. I'm not setting the password, not doing serial number. Won't include IP address, but I do just want to go ahead and request that certificate. We'll see the issuer was ksca.hop16.com. There's our subject name. And then we'll go through and do that on CSR2 and 3. Oops, got ahead of myself. I'm going to do CSR2. And I'll do that on CSR3. All right, so now all 3 of our routers that are going to be involved in Getvpn have, well, actually all 4 of our routers that'll be involved with Getvpn, including the key server, all have certificates. So now we can actually configure Getvpn, and we'll use certificate-based authentication. So crypto, we're just going to do Eigrp for this, but crypto ISAKMP, we'll say policy 10. Encryption is going to be AES 256, hash is SHA-256. We'll use group 19. We'll set a lifetime of 28,800 seconds. And we'll just grab this, because we can use that everywhere. Perfect. And again, if you've never configured Getvpn before, you'll find that the key server configuration is a bit heavy, and the actual router configurations, the devices that will be forwarding IPsec traffic and encrypting traffic is fairly light. So the way that this will end up working is CSR 1, 2, and 3 will form Eigrp phase 1 security associations with the key server. Over that phase 1 security association, the key server pushes out all of our crypto domain information to those routers so that they can encrypt traffic between one another. Hence, all the config actually kind of happens on the key server. The CSR config will be super light. That said, we'll just make this font a little bit bigger here, and we'll do crypto GKM or group key management. We'll have to come up with a group name. I'm going to do a really, really easy group name. That's just OTP group. And I'm actually getting a little bit ahead of myself here. I have to make some access lists first. So let's do IP access list, extend it. I'm going to call this access list rekey, and this will be the access list that the Getvpn config references for what IP addresses are used to do unicast rekeys. So I actually put my own key server IP address in here. It's 172.16.253.3, and it'll be permitted to go to any. Then I'll have to do another access list. This will be the actual IPsec traffic, the traffic that I want to encrypt. So we're going to permit Eigrp any, and we'll permit UDP any going to 4343, our Lisp data traffic. I'm fairly certain that this third entry will never get hit, because I don't know that we ever respond with a source port of 4343, but to be safe, we'll do both. And then we have to set up our IPsec phase 2 transform set. We'll call it ESP AES 256, SHA 256. And as the name probably gave away, we're going to do AES 256, SHA 256. We have to create an IPsec profile. We'll name it IPsec profile so I don't forget what I called it. We're going to set the transform set as the transform set I just made. All right, now we can actually go into our Getvpn config. So crypto GKM group, and then the group name that I'm going to use is OTP_group. I'm going to set an identity number to identify this group. I'll use 47884. I'm going to set the server as local. I'll set the address that I'm going to use as the IPv4 address of 172.16.253.3. And then I'm going to put some rekey. Some of this is optional. Like I'm going to set a rekey algorithm, and I'm going to specify to use a ES256. I'm going to set a rekey hash algorithm, a sig hash, as SHA-256. I'm going to set the rekey transport as unicast, and I'm going to set the rekey address to match the access list rekey that we created up here. And oh yeah, if you show crypto key RSA or my pub key RSA. There we go. And the key name that I'll have to use will be the private key associated with the certificate that I created for myself. So not the actual CA certificate's private key, or sorry, not the CA certificate's public key, but the client certificate that we registered after that public key. Which will be easy if you're doing if you're kind of following along. It'll be the last public key available on this string, be the most recent one. So the name of that key pair was ksca.hop16.com. So I will say rekey, authentication, my pub key, RSA, and then that key pair name. All right, so that's the bulk of the server config. Now we're going to set the security association parameters. It's IPsec. This will be the first entry in that list, only entry for us. And we're going to say the profile is the IPsec profile we defined above that had that transform set for AES 256, SHA 256. We called that profile IPsec profile. And then we have to give it an access list of what traffic to match. And that will be the access list I called IPsec, which might still be up here. Yep. That says what traffic we're going to match for phase 2. And that's it. Yeah, fairly config heavy on the key server. And then in contrast, when we come down to this Getvpn client, all we'll have to do here is do crypto, group key management, group, TP group. We'll reference that same identity number that I set up on the key server, which is 47884. We'll set the server's address as an IPv4 address of 172.16.253.3. And we'll say crypto map, OTP map, first entry, and it's a GDOI entry. We'll call the group that we just set up. And then we apply that crypto map on our WAN interface. And if that worked, we should see a install policy success. Then we'll start receiving some error messages because these clients aren't configured with Getvpn yet. So we'll see Eigrp goes down, all that. So let's fix that really quick. Say crypto VM, the group, OTP, the identity number of 47884, the server's address, 172.16.253.2. We'll make our crypto map, OTP map, first entry, GDOI, set the group as OTP. Just copy this really quick. Put it into Notepad. Yeah, and I named the group differently on R2, but worse things have happened. That actually doesn't matter, so long as the identity number matches up. Oh, I got the address wrong too. Whoops. Here, let's fix that really quick. Copy and paste is your friend. All right, so now let's put this on R2. Oh, what doesn't it like here? Oh, there we go. All right, then we see Eigrp comes back up after we get that successful installation of policies. And then finally, we can do this on CSR3. And we should see Eigrp come back up. We can do show crypto GKM. We can verify that we have this access list. I don't know if you can do show access list on this or not. No, you can't. We can verify that we are registered. Oh, here's the downloaded access list. We can verify that we got this interesting traffic ACL downloaded. You can see our key policies, all that good stuff. You can also do show crypto IPsec SA and see that we have packets decapped on this first security association. We have some end caps on this security association. You can see this is for protocol 88 or Eigrp. The important part here, you'll see this is all ESP traffic now, but if I try to ping 10.2.2 from my loopback 0, If this were like a traditional IPsec tunnel, we'd have to wait until a security association formed between CSR 2 and 3. So typically your first packet would drop, but with Getvpn, since we have this shared key server and a common IPsec SA, you don't lose your first ping or anything. You have immediate encrypted communication, as you'll see here. No first ping drops, nothing, and then all the traffic is encapsulated security. So all ESP traffic, all encrypted. We don't see the clear text pings anymore like we did somewhere way at the beginning of this capture with this filter. Yep, so this is all gone. Now everything's encrypted. And that's all I wanted to accomplish with this video. I'll do my best to share the start configs that I have and the finish completed configs somewhere in the video description. I know people like to download those sometimes and try and replicate this stuff. But anyway, I hope you guys enjoy this. I thought it was super interesting. I have no idea if it has any real world application. I think people are going to mostly use Getvpn if they want to encrypt WAN traffic and use transport mode IPsec. That's the most common application. But I did think it was nice that if you wanted to use Eigrp over the top, but also wanted to encrypt your communications, this was a pretty slick way of accomplishing that. Anyway, thanks for your time. Hope everyone enjoyed this. Have a good one. Bye.